Welcome to this new lecture of Master Computer Vision with OpenCV in Python. In this lecture, we show how to approximate contours in an image in Python using the OpenCV module. OpenCV has functions that can locate and approximate contours in the image. OpenCV has a function cv2.prox.tp that allows us to approximate contours in an image. What is approximating contours? Approximating contours allows us to straighten out various contours to make them curvy or messy. Lines that are not straight may be straightened with the help of this function. Things of that sort occur with approximation. It is very good when an image has outside nice or jagged edges that are better straightened. Okay, now we see this image. The contours of this image are the boundary lines of this image, and the line, you can clearly see that the lines are not so straight. These are curly or messy lines. And now we draw the contours of this image is tough. So therefore we need to approximate these contours so that we draw our contours on this boundary exactly on this curly or messy boundaries. Now we start our code. First of all, import required libraries, import cv2, numpy, znp, and drawing library matplotlib.plt, which is used for drawing images on the screen. Okay. Run the cell. Okay. The next cell, we read our original image whose contours are to be approximated. Our image house.png and stored in image folders, and image folders uploaded on my Google Drive. This is the path of our original image, and this is the function of cv2 imread, which is responsible to read images from this path. Okay, and now we have a copy of our original image, and image.copy stored in this variable. Now where we need a copy, actually original image is changed after the approximation of contours or drawn contours on the image. So therefore we need an original copy of that original image. Okay, this block of code is the responsible of showing original image. This line of code show method is used for showing images. This is the plt.title gives the title of original image, which means there is no need for Xscape and also for Xscape. Run the cell and see our image. This is our original image and whose contours or boundary lines are to be approximated. The first step, convert image into grayscale image. cv2.call cv2 color function, which means convert colors, and pass image as its first parameter argument, and the second argument is cv2.color_bgr2.gray. Actually, this line of code convert our bgr image into grayscale image. And the next, get edges of image through Canny detector. Canny is an algorithm which detects or extracts the edges of an image. Edges are continuous lines of an image. Okay, cv2.call Canny function, pass our gray image, and minimum threshold pass, and this is the maximum threshold. Show Canny and Canny image. Show Canny actually edges. These are the Canny edges of image. Okay. In the next set, we find contours of our image. Okay. Contours, hierarchy, contours, cv2.find contours method. Pass the Canny edges. This is the method of mode of contours. Actually, this returns the list of all contours, and this argument returns the all points of contours lies on the contours. Contours are stored in contours hierarchy. It's mean this represents the relationships of contour. Okay. Iterate through contours list and find the bounded rectangle which forms the contours in an image. For C contours, C is the loop variable, contour is the list of contours, X is the initial coordinate, actually X and Y are the top left regional, top left region, top left coordinate and region. W is the height, W is the width, and H is the height. And call the bounding rect function C. This function actually returns all rectangles which form our contours of an original image. Okay, rectangle is equal to CV2 rectangle, pass our original image, our region coordinate of these are the coordinate of region, and this is the width of rectangle, and this is the height of rectangle. This is the color of rectangle, and this is the thickness of color. Okay, what is this function? This function actually draw rectangles of contours on original image. Show our original image with rectangles which formed by our contour lines. Okay, listen. This is the image where we draw our rectangles where contours are formed. This is a contour rectangle, and we draw a rectangle on this, and this is also a rectangle. This is also a rectangle, and this is also a rectangle. This is also actually where contours of an image form a rectangle. We draw a rectangle on them. Okay. Next. Now we approximate our contours of an original image. Okay. Iterate through contour list and approximate the contours. Approximation means we draw exactly our contours in an image. It means this contour is exactly on this line, drawn this line on our boundary. Okay. For C and contours, this is low variable contour is the list of contours. Calculate approximation accuracy on perimeter. Accuracy 0.01, CV2 dot arc length, pass the contour, and true. What is this function? Okay. Arc length is mainly length of arc, because in this image contours are not straight lines, they contain a small curve, so therefore in form of arc, so therefore this is the accuracy of contours. Approximate. No, CV2 dot approx polytp, which means take our contours and then we pass accuracy. True mean is our shape is bounded. What is bounded shape? This is bounded. It means closed on all sides. Okay. Now we draw contours on our original image, which is a function we already see in the previous lectures. Draw contours. Functions take image, approximation. 0 means number of contours. 0, 0 to 55 is the color of our contours. Okay, which are approximated, and 1 is the thickness of color. Show original image with approximate contours. Okay, now you can clearly see that our contours are exactly drawn on the boundaries of our image on every shape inside the image. Okay, thank you very much. See you in the next lecture.